Hey there, and welcome. Ever stop to think about how your favorite app knows it's really you? Or how it decides what you're allowed to see, and then keeps a perfect record of everything you do? Well, today we're pulling back the curtain on AAA security. This is the absolute bedrock, the guardian of our entire digital world. And the easiest way to get our heads around this, let's imagine a castle. This is a fantastic way to visualize three very different but totally connected ideas. Authentication? That's you at the main gate. Authorization? That's the guard with the keys. And accounting? That's the scribe watching your every move. We're going to keep coming back to this. So here they are, the three pillars, the AAA. First, authentication, which answers one simple question: who are you? Then authorization, which asks, okay, what can you do? And finally, accounting, which tracks, what did you do? These three things working together are what decide who gets in, what they can touch, and crucially, who's on the hook if something goes wrong. So let's start at the very beginning, the castle gate. This is the first hurdle, and honestly, it's the most critical step. Before anything else can even happen, the system has to be sure, like 100% sure that you are who you say you are. That, my friends, is authentication. So what's actually happening under the hood? Well, authentication is really just a verification process. You show up with your credentials, a username and a password, and the system digs through its records to see if they match. It's basically the digital version of a bouncer checking your ID at the door. Seems simple, right? But how do you really prove it's you? Well, it turns out proof really boils down to just three categories. You can prove your identity with something only you know, like a password or a PIN. Or you can use something only you have, like your phone buzzing with a new code. And finally, there's something you are, your unique biology, like a fingerprint or a face scan. Each of these is called a factor of authentication. Now, this is where security gets really, really powerful. You start layering these factors on top of each other. You've heard of two-factor authentication, or 2FA, right? That just means combining any two of those factors. Multi-factor, or MFA, is the same idea, it just means using two or more. The more layers you have, the tougher it is for a bad guy to get in. And hey, here's a quick tip you can literally use right now. We're always told to create these crazy complex passwords that are impossible to remember. But you know what? A long, memorable passphrase, 4 or 5 simple words strung together, is often way, way stronger. Why? Because it's easy for you to remember, but an absolute nightmare for a computer to guess. Okay, so you've proven your identity. The guards have let you through the main gate. You're inside the castle. So now what? Well, that brings us to authorization, which is all about figuring out which keys you get handed. I mean, think about it. This is the next crucial question. Just because you made it past the front gate doesn't mean you get to roam free, right? Can you waltz into the royal treasury? Can you go into the kitchens? What about the king's private chambers? This is the exact problem that authorization is designed to solve. So if authentication answers, who are you? Authorization answers, okay, got it, now what are you allowed to do? It's the whole system of rules and permissions that defines your access rights. It's that guard at the treasury door, checking a list to see if your name is actually on it. And if you remember just one thing from this section, please make it this: the principle of least privilege. This is probably the single most important idea in all of authorization. It means you give every user the absolute bare minimum level of access they need to do their job, nothing more. This principle is also, unfortunately, one of the most ignored, and that's what leads to some of the biggest security breaches you hear about. So how does the system actually grant this access? Well, there are a couple of popular models. The most common is role-based access control, or RBAC. It's pretty simple. Your permissions are tied to your job title. You're an engineer, you get to see the code. A more advanced and frankly cooler model is attribute-based, or ABAC. This one looks at context, not just your role, but maybe the time of day, your physical location, or even the type of device you're using. All right, we've proven who we are, we know where we can go. But there's a huge piece of the puzzle missing. What happens if something goes wrong? Who's accountable? That brings us to our final A, accounting. This is our castle's official scribe, sitting quietly in the corner, taking notes on absolutely everything. This is where accounting, or auditing as it's often called, comes into play. It's all about creating an unchangeable record. It logs what users are doing to create an evidence trail. So this isn't about stopping something bad from happening in real time. It's about making sure that every single action is traceable back to a person. It's about accountability. So what's actually in this scribe's log? All the juicy details you need for an investigation. Who did what, exactly when they did it, and from where. You can think of it like a digital crime scene. If a critical file gets deleted or some data gets stolen, this log is the first place investigators are going to look to piece together exactly what happened. And here's a perfect, bite-sized example of how it all works together in harmony. An admin logs in. Boom, that's authentication. The system confirms they are authorized to access a super-sensitive firewall file. They make a change, and that action is instantly logged by the accounting system. See? All three A's working in perfect sync. Now, that castle metaphor has served us really well, but it has one tiny flaw. It kind of assumes that once you're inside the castle walls, you're trusted. In today's hyper-connected world, that is a dangerous, dangerous assumption. So the model has evolved into what we now call the zero trust fortress. The old way of thinking was all about the moat. Make it really hard to get in. But once somebody's inside, they're probably fine. Zero trust completely demolishes that idea. It assumes that threats can come from anywhere, even from people already inside your network. So it trusts no one by default. So the mantra here is simple, but it's an absolute game changer. Never trust, always verify. It doesn't matter if a request comes from inside or outside, it's treated as potentially hostile until proven otherwise. Identity is checked constantly, and access is only granted for the specific task at hand for the shortest time possible. Okay, let's bring it all home. What are the big takeaways? Authentication is all about proving who you are. Authorization is about deciding what you can do. And accounting keeps track of what you did. And running through all of that are two golden rules. Always, always enforce least privilege. And in our modern world, verify constantly. And really, this is the most important thing to walk away with. Security isn't a gate you just pass through one time. It's a living, breathing, ongoing process of checking and rechecking, making sure that trust is never just assumed. It has to be earned over and over again. Which really leaves us with a final thought. We love to think of security as this big wall we build. But as we've just seen, it's not a wall. It's a process. And that makes you wonder, doesn't it? When it comes to your own digital life, are your keys truly secure?